Okay, so let's unpack this because, well, think about it. If you take an elite explosive athlete, like right before a championship fight, maybe 24 hours out,
Right.
and you repeatedly stab their calf muscle with a 50-millimeter needle, I mean, conventional sports science would tell you that you've just completely ruined their performance.
Oh, absolutely. Yeah, the working theory for decades has basically been that inducing that kind of, localized mechanical trauma right before you compete, it just leaves the tissue damaged.
Sore and just totally incapable of firing at max capacity.
Exactly. But there's this massive study that just completely inverts that logic. It basically proves that inserting that needle doesn't cause clinical trauma at all. It actually acts as almost like an immediate biological reset button for the muscle.
Which is wild, and that's the mission for today's deep dive for you listening. We really want to investigate exactly what happens inside the muscles of these elite fighters when they undergo dry needling.
Yeah, we're looking at the hard data to see if treating these invisible muscle knots actually hinders or helps explosive physical power.
And we're pulling this from a really fascinating piece of academic literature published in 2024. It's from the Journal of Sports Science and Medicine. The article is titled, Acute Effects of the Dry Needling Session on Gastrocnemius Muscle Biomechanical Properties and Perfusion with Latent Trigger Points.
That's quite a title.
Yeah, and it's a single-blind, randomized controlled trial in mixed martial arts athletes, authored by Robert Trybulski, Arkadiusz Stanula, Aleksandra Żebrowska, Mieszko Podleśny, and Barbara Hall.
What's so great about this research is that it bridges this really crucial gap. You have clinical rehabilitation on one side and high-performance sports science on the other.
Right.
So we're moving away from looking at dry needling as just, some off-season physical therapy tool, and we're actually examining it as a viable pre-competition performance enhancer.
Which brings us to the athletes themselves. To really understand why the researchers use these needles, we have to look at the subjects. Mixed martial arts athletes. I mean, you are looking at a population that is just exposed to extreme physiological demands.
Oh, extreme is almost an understatement. These fighters are constantly cycling through excessive static loading, like when they're holding a sustained ground submission, right?
Yeah, just squeezing with everything they have for minutes at a time.
Exactly. And then they immediately switch to explosive dynamic loading.
Yeah.
Repeated sprinting, kicks, punches.
And that brutal oscillation between energy systems, it just creates a perfect storm for tissue degradation, doesn't it?
It really does. The mechanical stress alone causes damage to the myocyte membranes, the muscle cells. And those sustained static contractions, they induce local ischemia.
Which is restricted blood flow, right?
Right. So the tissue is essentially being starved of blood. And this chronic metabolic and mechanical overload, it basically sets the stage for the main culprit we're talking about today.
Latent trigger points.
Yes. Latent trigger points, or TRPs,
Yeah.
they form as these really hypersensitive nodes within a taut band of skeletal muscle.
And the literature points out a very specific location for this, right? Like they consistently develop near the motor end plate of the muscle.
Yeah, they're defined by this phenomenon called end plate noise.
Okay, wait, what is end plate noise?
So it presents as these spontaneous, very low amplitude electromyographic discharges. Basically, the muscle is trapped in a state of continuous, unnecessary electrical firing.
Wow. So it's just buzzing on a microscopic level.
Exactly. And because of that localized tension and the constant electrical static, the tissue experiences severe local hypoxia.
Lack of oxygen.
Right. Blood just cannot flow freely through that contracted little node, which means metabolic waste products, things like CO2 and lactate, they just become completely trapped in the microcirculation.
So for the listener, if we think of a healthy functioning muscle fiber, kind of like a specialized bungee cord, right? It should stretch smoothly and snap back, transferring energy efficiently.
That's a great way to picture it.
A latent trigger point is essentially like taking that bungee cord and tying a really tight, dense knot right in the middle of it.
Yep.
And the operative word in the study is latent, because the athlete might not even feel active pain during baseline movement, right? Like it only registers as pain if you actually press on it.
Exactly. But what's fascinating here is that even without that active pain, that little latent knot fundamentally alters the biomechanics of the entire muscle structure.
Because the bungee cord can't stretch properly anymore.
Right. The microscopic changes have huge macroscopic consequences. That single node increases the overall stiffness of the calf muscle, the gastrocnemius, and reduces its elasticity.
So the surrounding muscle tissue just has to work that much harder.
It has to expend significantly more energy just to achieve the exact same output. And that makes the athlete super susceptible to premature fatigue. It throws off their kinetic chain and drastically increases the risk of a severe injury during a fight.
Which brings us to the intervention. Because this knot is so deeply embedded in the fascia and it's trapping all this waste, passive interventions like just doing some static stretching, they aren't going to fix it. You can't just, stretch out a chemical bottleneck.
No, you really can't. The researchers knew they needed a highly targeted physical intervention to get in there and basically disrupt that end plate noise. So enter dry needling.
And they set up this really rigorous randomized controlled trial. They took 20 elite MMA athletes and split them into two groups. The experimental group, which they called EDN, and a placebo or sham group, QDN.
And the specific parameters for the intervention are pretty intense.
I'll say.
For the experimental group, the clinician used sterile soma needles. They measure 0.30 by 50 millimeters.
50 millimeters? That is a very long needle to be putting into a calf.
It is. And they inserted them directly into the medial head of the gastrocnemius, deliberately hunting around for those latent trigger points.
So they were looking for something specific when they did it, right?
Right. They performed 3 to 5 punctures per trigger point in about a 15 to 30-second window.
Right.
But the key is they were looking for local twitch response.
Yeah.
Or LTR.
Meaning the muscle actually physically jumps.
Exactly. Seeing that twitch indicates that the mechanical puncture successfully disrupted that taut band of tissue.
Okay, but playing devil's advocate here for a second, and I think a lot of coaches would flag this immediately. You're taking an athlete who relies totally on explosive power.
Right.
And you are repeatedly stabbing their calf muscle with a 50 millimeter needle just a day before a fight. Doesn't that cause, micro-trauma? Doesn't it ruin their performance?
Well, that's exactly the stigma this study was trying to challenge objectively. Coaches are terrified of microtrauma right before a bout.
Yeah, understandably.
But the researchers looked at established animal models to contextualize this. There's one model where scientists subjected a single muscle site in mice to 15 repeated needle punctures.
15 in one spot.
Yeah. And even with that extreme volume, the mechanical disruption did not interfere with the natural muscle regeneration process at all. The trauma was basically clinically insignificant.
So maybe the fear comes from people confusing dry needling with, blind acupuncture?
I think that's a huge part of it. And that distinction is vital. The American Physical Therapy Association defines dry needling as a highly skilled, very specific intervention for neuromusculoskeletal disorders.
Yeah.
You aren't just placing needles generally. The clinician is actively manipulating a specific pathological node.
Got it. Now, to make sure this wasn't all just a placebo effect, they had to design a sham therapy for the control group.
Right, because the athletes would know if they weren't getting poked.
Exactly. So they used this telescopic quasi-needle. It's basically a fake needle with a hidden spring inside. So when it presses against the skin, it perfectly mimics the feeling of a 50 millimeter puncture, but it never actually breaks the skin.
And since the athletes are lying face down on the table, they can't see it. So the single blind condition is strictly maintained.
So once the intervention is done, how do they actually measure the results? They couldn't just ask the fighters, hey, do you feel better? They needed real objective technology.
Right. They used a suite of tools that are basically the gold standard for this stuff. First, to measure the blood flow, they used laser Doppler flowmetry to measure blood perfusion.
This makes so much sense because you want to see if blood is returning to that hypoxic knot, but you obviously don't want to cut the athlete open to check.
Exactly. So the LDF bounces light waves off the erythrocytes, the red blood cells flowing through the capillaries at a depth of about 2.5 millimeters.
So it's literally tracking the cells moving under the skin.
Yeah, it gives them real-time data on the exact volume and velocity of blood flowing into that previously starved area.
That's incredible. And then they measured the biomechanical properties using a device called the Myoton PRO.
Right, the Myoton PRO. It applies this precisely calibrated mechanical impulse to the muscle, about 0.4 newtons, and then it calculates how the tissue physically responds.
It measures three things, right? Muscle tone, which is the resting tension, dynamic stiffness, so how much the tissue resists contraction, and elasticity.
Yes, and the way they measure elasticity is brilliant. They calculate the logarithmic decrement of the tissue's natural oscillation.
Okay, break that down for us. What does that actually mean?
It basically measures how rapidly the mechanical energy from that impulse fades out. If the oscillation fades quickly, it means the tissue is highly elastic. It can store and release mechanical energy efficiently.
Like our healthy bungee cord.
Exactly.
Okay, so they have the blood flow, they have the physical tension of the muscle, but they still needed to test raw power.
Right, the athletic output. They measured the pressure pain threshold using an algesimeter. But the most critical metric was the reactive strength index, the RSI.
And to test this, they had the athletes do a 55-centimeter drop jump onto a set of force plates.
Right.
And for the listener, testing the RSI with a drop jump is basically like dropping a bouncy ball and measuring exactly how fast and how high it rebounds off the floor.
That's a perfect analogy.
The athlete drops off a 55-centimeter box, absorbs the landing, and then has to instantly explode upward into a maximum vertical jump. It precisely isolates their ability to switch from an eccentric muscle contraction into a concentric one.
It shows exactly how well that calf muscle can use the stretch shortening cycle. So when you look at this whole methodology, it's just a perfect package. The laser Doppler measures the blood going in, the myoton PRO measures the physical tension of the knot itself, and the force plates measure the raw athletic power coming out.
So let's get to the results, because this is where it gets really interesting. They measured all this baseline data, did the needling, and then tested them again at 1 to 5 minutes post-session, and then exactly 24 hours later.
And the numbers are staggering.
Yeah, like I was totally expecting to see a huge drop in power at the 24-hour mark because of the trauma, but the traditional coaching fears were just completely dismantled.
Let's start with the vascular data. In the experimental group, the guys who got the actual punctures and had those muscle twitches, blood perfusion, spiked by 58% in just the first 1 to 5 minutes.
58%, that is a massive biological reversal. You've got this starved hypoxic zone, and suddenly it is just flooded with microcirculation.
And it wasn't just a temporary flush. 24 hours later, blood perfusion was still 20% higher than baseline.
So the roadblock was just completely cleared out.
Yes, and the physical properties of the muscle mirrored that. At 24 hours, the intrinsic muscle tone dropped by 18%. Dynamic stiffness went down by 14%, and the elasticity of the tissue improved by 12%.
That is a complete structural shift, but the metric that really shocked me was the power output.
The drop jumps.
Yeah. The reactive strength index increased by 12% at the 24-hour mark.
Which is incredible.
They jumped higher, they spent less time on the ground between landing and launching, and this is exactly when the old-school sports science said they should be limping around with microtrauma.
And to top it off, their pain threshold increased by 21%.
Oh, wow, so it had a massive analgesic effect, too. And what about the control group with the fake needles?
Basically nothing. Only trivial, statistically insignificant changes across the board. So it proves that just the feeling of the needle did nothing. You physically have to penetrate the fascia to get these results.
Okay, so if we connect this to the bigger picture,
Right.
What is the biological why here? How does poking a 50-millimeter piece of sterile steel into a calf cause a 58% surge in blood flow and a 12% spike in power?
Well, the literature points heavily to something called the axonal reflex.
Okay, what happens there?
When the needle physically penetrates that taut band and triggers the muscle twitch, it mechanically disrupts the localized nerve fibers. And that stimulation causes the nerve terminals to immediately release these really potent vasoactive substances.
Like, what kind of substances?
Specifically, substance P and calcitonin gene-related peptide, or CGRP.
Okay, so if the latent trigger point is a physical knot causing a metabolic traffic jam, the needle isn't just mechanically untying it.
No, not at all.
The puncture is essentially acting as a chemical signal flare. It releases the substance P and CGRP, which forces the blood vessels to widen and basically just washes the whole jam away.
Exactly. That neurogenic inflammatory response causes profound vasodilation. That huge flush of blood physically washes out all the trapped metabolic waste. The CO2, the lactate, the inflammatory cytokines, everything that was causing the hypoxia is gone.
So wait, what does this mean for that electrical buzzing? Does that localized twitch actually reset the end plate noise we talked about?
It absolutely does. The physical disruption from the needle, combined with that chemical flush we just talked about, it breaks the cycle of that spontaneous electromyographic static. Interrupting that motor end plate noise physically restores the muscle's ability to contract and relax efficiently. And the reason you see those sustained effects 24 hours later, like the 20% increase in blood flow, is because the mechanical tension is gone. The muscle band isn't physically squeezing the capillary shut anymore.
Which means normal microcirculation can just keep flowing long after the initial chemical rush is over.
Exactly.
So because the electrical static is silenced and the waste is fleshed out, the calf muscle regains its perfect elasticity. It's not fighting its own internal resistance anymore.
Right, which explains perfectly why their drop jump performance went up. The muscle wasn't dealing with microtrauma at all. It was finally unshackled from this huge biomechanical restriction.
The practical application of this is it's paradigm shifting for high-performance sports.
Completely. The researchers concluded that because these benefits happen so fast and they actively increase explosive power, coaches and athletes can safely use dry needling between training sessions.
Or even 24 hours before a championship fight.
Exactly. It transitions dry needling from being just an off-season rehab thing to an active, immediate performance optimizer.
It's amazing. Far from ruining a performance, a single session flushes the muscle, drops the stiffness, and gives you raw power. But, looking at the microscopic scale of all this, it leaves me with the final thought to kind of mull over.
Yeah, it really forces us to reevaluate how we look at fatigue in general.
Absolutely. Because if a simple mechanical disruption, just a tiny needle, can instantly reset our neuromuscular efficiency just by clearing out some localized hypoxia.
You have to wonder what else is going on.
Right. Like what other invisible physical bottlenecks are actively limiting human performance right now just because we can't see the impaired blood flow? We spend millions on macro variables, sleep architecture, nutrition blocks, training cycles, but the true limiters of a championship performance might just be these microscopic, imperceptible little knots starving our tissues of oxygen.
It's a profound realization. Optimal performance might literally just be about finding the right localized reset button.
Absolutely. For anyone listening, if you want to dig into the exact statistical modeling, the methodology, and the deep biological mechanisms, I highly encourage you to read the full article in the Journal of Sports Science and Medicine published in 2024. And make sure you follow the channel and turn on notifications so you never miss another deep dive into the science of